You need to run background processes, whether it's syncing with the server for the freshest content or crunching data for your app. However, running background processes leads to a tricky compromise for the operating system. Even if 20 apps have requested very important background work, the app that the user is actually interacting with needs to run smoothly. Android Oreo introduces a radically different way to think about background services. Apps cannot run freely in the background. This has implications for apps launched from an implicit broadcast, as well as apps starting services in the background. Here's a quick list of affected APIs. Location APIs are also affected, but I'm not going to be covering these now. More details on location updates are in the notes below. These changes are true for all apps targeting O, but even if you don't target O, users can turn these limitations on, so you need to be aware of these changes anyways. First on the list of background behavior changes are services. Calling start service from the background will cause an illegal state exception. Now, this does not affect services started when your app is visible and in the foreground, nor does it affect bound services. Here are a few more situations where the app is considered in the foreground. When your app moves from the foreground to the background, there's a short grace period before your service is shut down. The service shuts down as if it had called stop self. Now, these changes affect everything that is a service. So, are intent services affected? Well, yes. Are pending services affected? Not when they're created, but when they are sent, so yes. This even affects services you start in the background that you intend to promote to the foreground. The good news is that there are a few options for saving your services. Unless your app is an alarm clock app, 90% of the time, your best option is to replace your background service with a scheduled job. While you are no longer allowed to start services in the background, job scheduling can do background work on your behalf. This allows the framework to take all the scheduled jobs with their different constraints and figure out which jobs to run when. There are a number of different solutions for job scheduling depending on your app's needs. I've linked to the documentation which explains the trade-offs, but if you want my advice, I would look into using Firebase Job Dispatcher and the new Job Intent Service. Job Intent Service is especially handy to replace Intent Service. Next is the temporary service whitelist. There are a few special cases listed here when the app will be temporarily whitelisted and act for a short period of time as if it's in the foreground. If you want to trigger work when data on the server changes, consider implementing Firebase Cloud Messaging on your server and app. If you use a high priority FCM message, you will receive that message immediately, even when the system is in doze. You will also get on that handy service whitelist, so you can start a service as if the app were in the foreground. Now, if it's a normal priority FCM message, the message is delivered when a user turns the device screen on or during the doze maintenance window. You are not whitelisted to start services, though. So if your app receives both high and normal priority messages, one approach is to try starting the service, and if for any reason that fails, have a fallback such as starting a job. If the service is something the user might interact with or want to monitor, you can make a foreground service instead. Foreground services have a persistent notification on screen, which informs the user that they're actually running. Timers and navigation apps are common examples of apps that employ foreground services effectively. The thing is, the old way of starting a foreground service from the background will no longer work. Instead, switch to the new API to start a foreground service. The steps are, first, use the new Start Foreground Service method. This creates a background service that you must immediately promote to the foreground. Within the service, make a notification. Your foreground service notification should always be of low importance or higher so that it's actually visible to the user. It should not be of mid importance. The final step is to have the service promote itself to the foreground using Start Foreground and the notification that you just made. If you need a pending intent to start a foreground service, you can use pending intent's new Get Foreground Service method, and then follow the same steps to promote it to a foreground service. If none of those options work for you, you might consider deferring your work until your app is in the foreground. Now, if you need to test your app under the new restrictions, I've also included links below with the ADB commands to make the app run in the background and to force background limitations for your app. Okay, let's switch to talking about implicit broadcast receiver limitations. Broadcast receivers that are statically defined and listening for implicit broadcasts will not receive those broadcasts. Implicit broadcasts do not have the target component attribute set, and static broadcast receivers are defined in the Android manifest. Prior to Android Oreo, implicit broadcasts would trigger any component listening for them in the manifest. Now, in resource-constrained situations, this would cause memory thrashing as a single broadcast triggered the creation of a bunch of different components from different apps. So here are your options for replacing static implicit broadcast receivers. Now, there's a short list of exceptions, so you should absolutely check that list first. If the broadcast is on that list, it won't be affected and it will function as normal. This list contains things such as changing locale or plugging in headphones. The full document is linked. If your broadcast is not on the exception list, you might be able to replace it with a job. Jobs can be triggered by the following conditions, some of which have been added in O. In particular, content provider observers can trigger jobs for a variety of situations, such as when the user saves a new picture on their phone. Now, if part of your app is already running when the broadcast is sent, you can switch to a dynamic broadcast receiver instead. This means moving your broadcast receiver code out of the manifest, and then you create, register, and unregister it during runtime, like I'm doing here. Even though these situations focus on background processes, the benefits will be felt for those using your app in the foreground, with less jank and fewer crashes. This will be even more impactful for users who don't have access to the most expensive or fastest hardware. I've touched on a number of strategies and API changes. If your app is affected and you want to learn more and get started with code examples, check out the documentation.